Hello, hello, hello! Here we are for part 2 of our water PowerPoint. Last time we talked about ice and solutions and specific heat. We're going to continue today. We're going to talk about cohesion, and adhesion. Cohesion is when like molecules stick together. And I didn't really mention this last time, I probably should have, but all of those properties, ice's ability to float, high specific heat, water as a good solvent, all of that stuff is due to water's polar nature. Well, it turns out the cohesion is also due to water's polar nature. In fact, all of water's properties are due to its polar nature. So we've got our oxygen and our hydrogen and our hydrogen. Oxygen's partially negative, hydrogen's partially positive, and cohesion would be this hydrogen bond. So we've got another water. And this hydrogen bond causes an attraction between like substances, which we call cohesion. Cohesion causes water to have a high surface tension. And surface tension is the force required to break the surface of a liquid. So it's very high because of the hydrogen bonding between the water molecules, and that hydrogen bonding is due to water's polar nature. There's also adhesion. Adhesion is when two non-like substances are attracted or bond together. And that causes capillary action. You're looking at a picture of capillary action now. Notice that the water has blue food coloring in it and that it's moving up the paper towel. Why is it moving up the paper towel? Well, it's bonding to itself. It's also bonding to the paper towel. And we call that capillary action. Let's define capillary action. So, capillary action is when a liquid moves through a narrow tube, and all that paper towel is, it's a flattened, narrow tube. There's very small spaces between the plant cells that make up that paper towel against the force of gravity, and capillary action is caused by cohesion and adhesion. Okay, let's talk about heat of vaporization. Okay, so the heat of vaporization is the amount of heat needed to change 1 gram of liquid to gas. And then just a quick review of solutions. We talked about this in the last PowerPoint. If this is a beaker and we've got a liquid and we add salt to that liquid, then this is the solvent and this is the solute. Just need to remind you of that so that we can talk about other stuff. Like a saturated solution is a solution that contains the maximum amount of solute. So you cannot dissolve any more stuff into that solution. It has the maximum amount dissolved into it. It is dependent on pressure, which in our everyday lives and in most biological systems remains constant or nearly constant. And this is the big one. Temperature. Everybody's had that experience where you're trying to make, say, Kool-Aid, and you can't dissolve all of the sugar, so you heat the water up, and magically it dissolves. Now, the downfall to that is when you cool it down, oftentimes that sugar will precipitate out of solution, and you'll be back where you started. When it does not precipitate, you have a super saturated solution is when the temperature is raised in a saturated solution to dissolve more solute, and when the temperature lowers back to normal, the solute remains dissolved. Often that has to do with the geometry of the solute and its interaction with the solvent molecule. Good news, when you're doing these PowerPoints, you do not need to do the review questions. That's food for thought if we had done those in class, but since we're not going to do them in class, no reason to do those review questions. In addition, I wanted to mention how happy I am with you guys, that you're wearing your mask and remaining socially distant. You're sacrificing for your grandparents, and I think that's totally awesome. Until next time, gang, take care.